is Mr. Alex Casas. Unfortunately, due to some issues, he couldn't come in person. If he wants, he will tell you by himself what was wrong with him. It's somehow connected with the presentation of Mr. Scheuer. But Mr. Casas, are you ready?
Yes. Hello, Laura. Thank you very much.
Hello. So I hope you're feeling well. Mr. Casas is the ecosystem lead at Aeternity. Am I right?
Yes, exactly.
Okay. So, and his presentation name is how to make most of Bitcoin's PoW on hyperchains, right?
Yes, exactly.
So here you are. I suppose I'm finished here. The word is yours, please.
Thank you very much, Laura. Yeah, unfortunately, these weird times and a fake result for a PCR test have prevented me to go there. Hopefully I feel perfect. So the PCR, yeah, it's a fake, but it prevented me to be there. Sorry for that. And thanks for having the opportunity to do this online. And hopefully we are also here to change a couple of things, like this kind of things to not happen. So still really, really happy to be here. It's also a very special talk for me because it's not only the first time that hyperchains are presented in public, but also it makes me a special illusion and excitement to be doing it at BlockchainUA. I was first in BlockchainUA in 2017, and I really miss my Ukrainian friends and my beloved Ukrainian community. So thanks everyone. Thanks Anastasia. Thanks PoW. Thanks. Thanks Vlad. Thanks to our wonderful MC. And yeah, without any more delay, I will share my screen to have a little presentation. Let me start it, please. Let's get started. Thanks again. It's a pleasure for me to be today representing Eternity and talking about hyperchains and the effect that it will have in making the most of Bitcoin's proof of work, improving the whole sustainability of the crypto space. First, I would like to give you a very, very short overview about who we are in less than the time of a microblock in Eternity network, which is 3 minutes, even though confirmations of transactions happened every 3 seconds. So first, the project was started by Yanislav Malachov, who is also said to be the godfather of Ethereum because of his early involvement in the development of Ethereum when it even have not a name. And if you want to check some nice piece of crypto history, you can look for that Medium post and learn a bit about those really, really early days. So the point was to design a blockchain from scratch to anticipate future problems that will come with future adoption, mostly about scalability, for example. So the core protocol implementation was written in Erlang. Some of you might know Erlang because it's used in highly critical and need for performance applications. Like for example, WhatsApp was built on Erlang. And in fact, 90% of the internet traffic goes through Erlang nodes, for example. So it's a very, very powerful and secure language when you want to run highly critical applications like blockchains are. The mainnet was launched in 2018. So if you look at the dates, we were one of the first smart contract platforms to be launched after Ethereum. And we have some features that make us, for me, the most advanced blockchain in production. And I always say that I don't say that Eternity is the most advanced blockchain in production because I work in Eternity, but I work in Eternity because I think it's the most advanced blockchain in production. So for example, thanks to the implementation of Bitcoin NG, we have a 3 seconds confirmation time, which allows us to have an on-chain throughput of 116 transactions per second, a tailored secure language based in functional programming for our smart contracts was developed, Sophia, together with the design of a highly optimized transaction engine, which is called the Fast Eternity Transaction Engine, which is optimized with several transaction types, which, for example, also allows that a Sophia contract bytecode is just 10% of, for example, the same contract in Solidity. For example, if you compare two smart contracts to deploy a token, one in Solidity and one in Sophia, the bytecode in Sophia is 10% the weight of the Solidity one. So it's much more efficient, allows us to process much more cheap transactions and faster transactions within the network. So this was also allowed because we were the first to implement the highly efficient Kuko cycle algorithm by John Trump. Now it's more known because it's used, for example, in Mimblewimble based coins like Green or Mimblewimble. And now we got to the point of our layer one, of our unique layer one. One of those problems identified has to do about easiness of development and security. So for example, oracles live in the nodes. They are an entity that are embedded in the protocol one and have a special kinds of account for posting and current results of the oracles. But this is not all what we can do in layer one. We can also run off-chain smart contract executions thanks to state channels, which provide virtually unlimited scalability with no fees and an enhanced privacy. Apart from that, also the naming systems for having human readable addresses is present in the protocol, and we are a blockchain with very low on-chain fees, which makes possible now the deployment of some use cases that wouldn't be economically viable with the fees that we are seeing in the market. Apart from that, since 2017, we are in the top rank of GitHub repos with more activity. And last, to finish this introduction and go to the topic of the talk, there is a vibrant ecosystem spread all over the world with more than 30 apps in production on mainnet. So where are we up to now? Yes, working in hyperchains. So hyperchains, we like to think about them like as it's a new consensus mechanism that we have developed as an open source contribution to universal blockchain scalability. In summary, and we will get deeper now, it's about a safe parent chain which provides a source of randomness for the leader selection in the child chain. And this consensus change is going to be proposed to the Aeternity community, as we are going to see after. So what has been lately happening in the space? It seems that we have had like a debate, fight, some tribalism, some discussions with defendants of proof of work and defendants of proof of stake. So it has been like some years of deep academic research to try to overcome the trade-offs of both consensus mechanisms. But our statement was like about, why can't we be friends? Why can't we work together and mix both consensus mechanisms to have like the possibility of continuing challenging the decentralization trilemma, like we did with Bitcoin and G, with hyperchains? We can have decentralization, scalability, and security while getting together the best of both proof of work and proof of stake worlds. So it's like, yes, what if we reduce existing hash of a network to secure more networks? And this is like a nice example. It's like, imagine in a nascent industry, some actor, some player in that industry might be producing himself a component that he needs for the production process. But later the market matures and he realized there is no longer needed to produce that component himself, but to go out and buy it already made to the best manufacturer out there. So here it's somehow the same. Before we were producing blocks with the standalone networks, but then we realized that we can use blocks that are already made and rent or leverage on that blocks and bought them and use the ones of the best manufacturer out there, the most secure and best provider of block hashes, which is Bitcoin. So it's like you already buy the blocks made to have that source of randomness that we'll need to secure the child chain. Remember, in hyperchains, you have a parent chain, which provides that source of randomness, and then you have a child chain, which has another consensus protocol In this case, in our case, it will be a proof of stake, but as we will see after, this also can be configured by any project. This is an open source. This is an open source contribution. So let's have a look to how it works. Like, imagine we have a validators. We are running a node. They receive delegations. They receive coins delegated from the stakers that want to make have a reward for their coins, but doesn't have the ability or doesn't want to run a node, and they are able to get rewards. Until here, sounds pretty familiar to a proof of work, proof of stake, traditional scheme. The difference here is that aspiring leaders, those validators, to have the chance to be elected as leaders, they should publish a commitment transaction in the parent chain, which gives the view of the state of the child chain at a given block. When that block in the parent chain is solved, all the transactions committed by aspiring validators that are there enter into the raffle, like based on that source of randomness on that block has under staking, under the legatees, they get the possibility, the chances of getting selected as leader. And when they are leaders, they just broadcast transactions to the network just by signing them, and they can do so until the next block in the parent chain is solved, in which a new leader will be selected. A very special thing about the protocol and how the staking works is, like, for example, the block rewards are never in the custody, goes directly to the delegator. The staking contract is a very crucial part of the protocol. In fact, all the consensus rules rely on the staking contract, and one of the main principles for design was to have a direct reward to delegators without sending the money first to the let's say staking pool, and then the staking pool sends to validators. So this is like a very high level overview of how it works. The new white paper and more materials will be published in days. So any of you that are curious about the technicalities and the more like deep details of Hyperchain's consensus will have soon all the materials they need to read about and realize the disruptive power of this new consensus protocol that is being developed by Eternity Foundation. So talking about the title, so this is like, and it's like simple maths. It's like really easy. When you start doing this, there is an immediate efficiency increase in Bitcoin network, because with the same consumption and with the same power, you are securing much more transactions. So these commitment transactions that are placed, in this case, in the Bitcoin network, allow millions of incremental transactions to be also secure by the Bitcoin network without an increment in the hash power. So this is automatically meaning that the individual energy consumption and emissions per transaction is dropping by a great factor, directly correlated to the amount of transactions in the child chain that are in fact now secure by the Bitcoin hash power. But this is not only the point. We have a double effect. On one hand, like we have already seen, we can increase the utility of Bitcoin network hash power, but also if a chain that is moving to hyperchains is a standalone proof of work, like Eternity is now, when moving to hyperchains consensus, it's not only that the Bitcoin network is securing that transactions, but that old proof of network, that standalone hash power, is eliminated and is substituted by that of the parent chain. So on one hand, you increase the efficiency of the parent chain transactions, of the Bitcoin transactions, and on the other hand, you just get rid and eliminate all the standalone consumption that was made under proof of work in the chain that is moving to hyperchains. So let's see how are we gonna, let's see the Eternity use case. Eternity will be the first network to be secured by hyperchains consensus, and this will be made first with a governance vote for the community to signal their interest to move to hyperchains consensus. But then there will be like on-chain vote, which is de facto binding, because what will happen when hyperchain consensus is deployed, there will be a transition phase in which people can start depositing their coins and validators can start making their safety deposits, and the network will be monitoring the economical security of the hyperchains because of the staked coins, and will be compared to the proof of work security. And when that security is higher in the staking contract or in the proof of work, nodes will automatically ditch down proof of work and will start issuing blocks signaling hyperchains with a special nonce. So we will have that de facto vote, because when people is placing their coins in the staking contracts, they are in fact voting to have hyperchains activated. And in the precise moment that the thresholds are achieved, the hyperchains consensus will be activated. So this is also very important for our whole community and also for our coin holders, because this change will allow people to delegate their coins and start earning rewards. And also, not only through validators, but it's our intention. We firmly believe in the centralization of infrastructure, and we are working on a very simple interface and one-click installation for anyone to be able to be a validator and to receive coins delegated from others. Good news, yes, there is code released before the white paper. Sounds familiar? Yes, there is a Docker image available, which is like the first private testnet release, which allows to perform simulations and to play around with a local environment with 3 nodes working against the Bitcoin testnet for people to try how the consensus mechanism works, still with limited functionality. But the next step will be our public testnet, in which we will start a bug bounty program and also an external security audit before starting with that process of starting to stake coins for the protocol to be able to be activated. And yes, I have talked about Aeternity and implementation of hyperchains in Aeternity, but we are committed to open source and to contribute to a more private, decentralized, and free world. So hyperchains have been designed from scratch, having in mind that it should be possible for others with a great degree of customization to deploy their own hyperchains. So it's really an universal way to scale blockchains, not only the Eternity network. For example, about parent chain, different connectors for the communication, for having the election of leaders can be developed for several chains, for whatever chains, but also the consensus mechanism in the child chain can also be customized and even change on the fly. So you can rather go for a proof of authority rather than a proof of stake, and you just you don't need like experienced Erlang developers to do that, because the framework is already made and thought of for that. So on top of that, and of course, hyperchains can be deployed in a public manner, but also in private, enabling like enterprise use cases, and also with the possibility, we have not get very deep in this, and I invite you to have a look to the white paper when it's out, because also hyperchains can be nested. So you can have like Bitcoin proof of work, then Eternity proof of stake anchored to Bitcoin hyperchains, but then you can have Eternity child chain of Bitcoin being the parent chain of another chain, and you can have plenty of those. You can start by increasing the transactions that are secure at the top level by the Bitcoin network by thousands, by factor of thousands. So we really think that this is like very good contribution to the whole crypto space sustainability. Pity that Elon didn't know this before start tweeting all the things that he's tweeting, but we hope that we can together, all the community, improve this sustainability of the crypto and the blockchain space using hyperchains as a way to increase efficiency on one hand of the existing and the most secure proof of networks, and also by eliminating a standalone proof of work that in fact is not really secure. Now, a chain with a low hash rate is very vulnerable to 51% attacks. When moving to hyperchains consensus, the security of the child chain is as high as the security of the parent chain. So when you move to Bitcoin hyperchains, if someone wants to do a 51% attack on your network, okay, come on, go on 51% attack the Bitcoin network. And yes, I would like you, if you didn't know Aeternity, to get involved in our incredible community by joining the forum at forum@eternity.com. In this QR, you can directly enter into our English Telegram group. There is also a Russian-speaking one. And also, if you are interested in knowing more about becoming a validator, just ping me, because there is, like, for example, for exchanges, for wallets, for payment processors, there is a very interesting use case, because transactions that were to be made in any case can be leveraged to place the commitment and the state of the child chain in the op return. So they will have the chance to get rewards without any incremental costs. So just ping me here, and I think this is all. Thanks a lot for the time and for the opportunity. And yeah, we are thinking blockchain out of the box again. Thank you very much. Any question?
Thank you for the presentation. That was pretty interesting one about scaling all those chains. And
thank you very much.
I want to congratulate you with your first presentation about hyperchains. I think that it was amazing. We so far do not have any questions. Thank you very much for this opportunity to be a host.
Thanks everyone, and enjoy one of the best conferences in the world. I can say, and I promise. Really, congratulations for an amazing work. See you.
Thank you.
Yeah, thank you very much.
Thank you very much. Hope to see you again. Bye-bye.
Take care.
Bye-bye. Thank you.